Good morning, children. Today we will continue with the chapter number 12, where we will be learning about the basic terms which we are going to learn, or which we are going to come across when we are learning organic reactions. So we had discussed about the electrophiles, the nucleophiles, electromagnetic effect, inductive effect. Okay. Now we will continue with that topic only. Next we will learn about resonance. What is resonance? Now, resonance is a phenomenon where you will find that the electrons are moving from the region of higher electron density to the region of lower electron density. What did I say? Resonance. Resonance is the phenomenon where you will find the electrons are moving from the region of higher electron density to the region of lower electron density. उसका एक एग्जाम्पल हम लोग लिख के लेते हैं where you find C. This is which compound? This is benzene, isn't it? So here benzene, you will find that there are alternate double bonds. That means this is where we can show that there is double bond existing between these two carbon atoms. Okay, it is existing between these two carbon atoms. The double bond here, this and this. So each carbon you will see there is alternate double bonds existing. So wherever double bonds are there, that means there is 4 electrons there. 2 pair means 4 electrons, and this is only 2. So the electrons are moving from the region of higher electron density. You can say this region is the higher electron density. From there it is moving here to the region of lower electron density. Again, this is the region of higher electron density, so it will move here. Okay? This is again the region of higher electron density. From here it will move to this region where there is less number of electrons. So now you will find that the structure has come to this way. So ऐसे जो structures होते हैं, they are called as resonance structures. Okay, या canonical structures होते हैं. This is first structure possible for benzene. This is second structure possible for benzene. So the electrons are continuously, and these electrons, which electrons are moving? Pi electrons are moving. डबल बॉन्ड में से हम लोग कहते हैं कि एक जो है वो सिंगल बॉन्ड होता है और एक पाई बॉन्ड होता है. पाई बॉन्ड is formed by lateral overlap of the electrons. So there is an electron cloud which is being formed. So these electrons which are moving, it is the pi electrons. So here we say that the pi electrons are delocalized. Delocalized means it is not having a fixed position. It will be continuously being rotated. So again here this is the structure it will be obtained. Now again this is the region of higher electron density, so the electron will move here. This is the region of higher electron density, so it will move here, and this will move here. So again you will get this the original figure. So this kind of phenomenon is continuously going on in a conjugated system. Now what is a conjugated system? You should understand. Conjugated system means where you have alternate double and single bond. पहले double bond, then single bond, then double bond, then single bond. That kind of a system is called as conjugated system. So this is resonance phenomenon which is occurring in the molecule of benzene. ठीक है? और ये benzene will have an intermediate structure. Actually में you will find that benzene is neither having this structure nor having this structure, but it is a resonance hybrid of this structure. That is why benzene is so with a circle inside. Okay, because there is continuous change of the pi electrons. The pi electrons are delocalized here. So it is continuously moving from one region to the other region. So therefore, this is the resonance hybrid. Okay, resonance hybrid of benzene. Okay. Again, another example we can take here. See, you observe here CH2, CH, Cl. This is a double bond. This is a single bond. This is a conjugate system. Here what happens? This is the region of higher electron density. तो वो यहाँ पे exist होगा. So what is happening here? This pair of electron is moving here double bond CH, Cl. Okay, so here the resonance hybrid of this particular structure is ये इलेक्ट्रॉन इधर मूव हो रहा है, so then this pair of electron which is in the form of a double bond it will move here. So the electron flow is occurring here, and now we have our ये minus sign आ जाएगा कि this carbon is gaining electron here, and this will be the single bond. Then you have CH double bond C plus sign. Are you following? So this two will be called as the resonance structure, ये canonical structure है. Okay? तो यहाँ पे this kind of an effect, it is called as positive R effect, plus R effect. जैसे हमने inductive effect सीखा था तो plus R, plus I और minus I effect देखा था. So this effect is called as plus R effect. That is, a group is giving or donating electron towards the double. That means it will be plus R effect. Now, there are certain other ways you can show it. See, the second example we will take CH2 double bond CH, C triple bond N. S. Now, this pair of electron moves here. Okay, so then what is happening? This pair of electron will move here. Okay, so now you have a resonance hybrid of this kind where you have CH2. So this carbon will acquire a positive charge, isn't it? So that carbon will acquire, this electron is moving here, the carbon will acquire a positive charge. You have CH double bond C. Here you have again double bond, minus sign, N के ऊपर. So can you observe here? This electron is moving towards N, and this pair of electron will move then here. Just observe the valencies of the carbon. Here C4 है 1, 2, 3, 4. Here also 2, 3, and there is a positive sign. Got it, everyone? So this is what we call as resonance effect. And here what is happening? In the second example, the double bond का जो electrons है is being withdrawn by this group C here. तो ऐसा जो effect आया that is called as minus R effect. It is called as minus R effect. Clear or not? So here from the double bond the group is taking away the electron, and here you will find the group is donating the electron towards the double bond. So ये plus R effect और ये minus R effect. Now when I say plus R effect and minus R effect, we can just see the definition how it comes. The flow of electron from one part of the conjugated system. Now you have understood now what is conjugated system, alternate, double and single bonds. Okay, conjugate system to the other, creating centers of low and high density. At certain region you will find higher number of electrons, certain centers you will find lower number of electrons. अब यहाँ पे तो अपने आप से हो रहा है, but here you will see that this group is the reason why the electron flow is taking place. The nature of this group is to donate the electron towards the double bond. Therefore, ये effect को हम कहते हैं plus R effect. ये जो हम बोल रहे हैं, this is the resonance phenomenon which is occurring when we discuss about the balancing. Okay, centers of low and higher electron density due to the phenomenon of resonance. So resonance, in a simple way, you can understand that it is the movement of the flow of electron from the region of higher electron density to the region of lower electron density. Okay, so when we say it is a minus R effect, when groups are there which donate, which takes the electron towards itself from the double bond, while positive R effect is those groups which donate the electron towards the double bond. So that is your positive R effect. Clear, everyone? Okay. Now come to hyperconjugation. Okay, before going to hyperconjugation, let me give you some examples where you can find resonance effect. All of you have learned, no, that CO3 2 minus. इसका structure क्या है? We had seen that C ऐसा था. If you remember when we were doing chemical bonding. This was the structure. Now, not necessary that this carbon, here you will find the oxygen will have 2 pair of orbital, here 3 pair. Here you will find that it is not necessary that this oxygen only will be having a double bond. Again, the resonance structure you can show in this way. Here O with minus sign, here O minus sign, double bond O. Okay? तो ये हमने उस टाइम भी डिस्कस किया था when we were doing chemical. Okay? So again, carbon can have double bond with this carbon also. This oxygen is negative charge. This oxygen is having negative charge. इस तरह से, ठीक है? So ये resonance and resonance effect. Now next is hyperconjugation. अब यहाँ पे हर जगह पे देखना, कहीं पर भी सिग्मा बॉन्ड का इलेक्ट्रॉन्स मूव नहीं कर रहा है. अब दे also already the double bond or the multiple bond का जो इलेक्ट्रॉन्स है that those are moving. Now when we talk about hyperconjugation effect is what? The sigma bond electrons are being delocalized. That is, it is moving towards the double bond. Okay? So therefore, जब ये pair of electron is moving here, the pair of electrons will move here. Always, the hydrogen which is having a sigma bond with the carbon, वो hydrogen it should be the alpha hydrogen. That is, alpha hydrogen means the carbon which is next to the functional group. Now double bond is a functional group. So therefore, the hydrogen between the hydrogen which is just next to the carbon which is having double bond, that bond will be delocalized. अब ये sigma bond है, अब ये pair of electron क्या हो जाएगा? इधर आ जाएगा. तो अभी इधर हाइड्रोजन के पास इलेक्ट्रॉन नहीं है, वो पॉजिटिव चार्ज ले लेगा. So I will just show how the structure will become now. It will become H, C. Now there is no bond between the hydrogen and the carbon. And here we have a double bond with CH2 and a negative charge. अब ऐसा सिचुएशन होता है तो ये हाइड्रोजन और कार्बन के बीच का जो सिंगल बॉन्ड है it will move here. Okay? So now what is the structure you will have? You have H. Here there is no bond. So and this hydrogen will have a positive charge. Here you have H with plus. Here H and here double bond CH and CH2 minus. So this is how you will have your structure. Clear? Now what happens? This pair of electron between the carbon and hydrogen will move here. So here hydrogen, carbon, hydrogen. Here it won't be plus. Okay, that bond is already occurred. So here अभी इस हाइड्रोजन के ऊपर प्लस चार्ज है और यहाँ पे कोई बॉन्ड नहीं है और इधर डबल बॉन्ड है CH and CH2 minus. So there is a continuous rotation of this sigma bonds. That is, it is getting delocalized. और ऐसे इफेक्ट को हम कहते हैं hyperconjugation effect. Now what will happen? This pair of electron will move back here and this will come back here. तो ये जो इफेक्ट है, this is called as hyperconjugation effect. और hyperconjugation effect को या resonance को it makes the molecule more stable. तो जितना ज़्यादा hyperconjugation एक molecule में दिखेगा, more stable will be the complex, more stable will be the molecule. अब benzene, why it is very stable in nature? That is because of this resonance, and because of the resonance, the energy level of this molecule decreases, and that energy is called as resonance energy. Okay, so resonance energy will be lower for this molecule, because of which it is more stable. Okay, then another thing, if I say CH3CH double bond CH3, ये हमें कहाँ पे यूजफुल होता है? Just we will try to understand that. The hyperconjugation effect, where is it being useful to us? two molecules. Okay, here there is a CH3, C double bond, C, CH2. ऐसा है. Here you have CH3, C double bond, C and H. Okay, one more molecule we can take CH3, C double bond, C, CH3, or instead of writing it this way, I will write it in a different way so that it becomes more clearer to you. CH3, यहाँ पे भी CH3 है, okay, यहाँ CH3 है और यहाँ पे एक सिंगल H. तो ये सब मॉलिक्यूल्स में you see, if you are asked which one is more stable, so then how can you find out which one is more stable? जिसमें सबसे ज़्यादा हाइड्रोजन कॉन्जुगेशन है, that will be more stable. So you can see here कि the carbon, this is the double bond, and the carbon next to the double bonded carbon is this, or it can be this. अब यहाँ पे there is hyper conjugation possible. यहाँ पे देखो H होगा, यहाँ पे H होगा, यहाँ पे H होगा. This pair of electron will move here. Okay, so this electron, ये जो between the, sorry, this should be bonded to carbon. Okay, as H, H, H. So what will happen? ये जो pair of electron है वो इधर move हो जाएगा और यहाँ पे double bond आ जाएगा. No bond resonance है. इसको no bond resonance भी कहते हैं because there is no bond here between the hydrogen and the carbon. That is why it is also known as no bond resonance. So again same procedure will occur here. So there are how many hyperconjugation possible here? ये 3 CH bonds है यहाँ पे यानी 3 और यहाँ पे भी 3 CH bonds है यहाँ पे भी 3. So total 6 hyperconjugations are possible in this molecule. अब इस molecule में कितना hyperconjugation है? So 1, 2, 3 carbons with CH3, 3 bonds. So now total 9 hyperconjugations है यहाँ पे. यहाँ पे only 3 hyperconjugations are possible. Okay? So among them which is most stable बोलेंगे तो सबसे ज़्यादा stable जिसमें सबसे ज़्यादा hyperconjugation है. मतलब जिसमें सबसे ज़्यादा CH sigma bonds है. CH sigma bonds. So there are 9 here, there are 6 here, there is 3 here. अगर दोनों ही कार्बन में there are CH3 groups इस तरह से. So then there are 12 hyperconjugation in this molecule. So सबसे ज़्यादा stable ये होगा. So here you will find 12 hyperconjugation. 12 hyperconjugation. ठीक है? यहाँ पे there is 3 hyperconjugation. ठीक है? Here you have 6 hyperconjugation. Hyperconjugation is the movement of the sigma electrons between the carbon and the hydrogen. यहाँ पे you will find क्या इधर 6 है, इधर 9 hyperconjugations. So most stable is this 12 one. Okay? वैसे ही resonance में जितना ज़्यादा resonating structures है उतना that much more stable it is. I hope you understand resonance effect and hyperconjugation effect. Okay? So you can copy down. Now we will learn about reactive intermediates. Reactive intermediates मतलब in a particular reaction there is some intermediate molecules or species formed that is very short-lived, it is highly unstable. So those kind of species will be called as reactive intermediates. और उसमें सबसे पहले we will learn about carbocations. Now what is carbocations? The chemical species where the carbon carries a positive charge. Carbon carries a positive charge on it or consist of 6 electron is called as a carbocation. For example, let me take CH3, CH2, molecule occurs heterolytic fission. Okay, heterolytic fission of this molecule takes place. This pair of electron moves towards the chlorine, and now you have a carbon which has a positive charge and Cl with a negative charge. Heterolytic fission. मतलब in heterolytic fission you will generate a positive ion and a negative ion. This positive ion which has a carbon with positive charge, this is called as a carbocation. Okay, carbocation. Okay. Again, whenever a carbocation has a carbon with positive charge bonded to one carbon only, then it will be called as primary carbocation. Okay, what do we call that? Primary will be denoted by 1 to the circle. So here primary carbocation. Okay, if you have CH3 thrice, or I can write it in this way, CH3, 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 Ca. Now here you can find this heterolytic fission occurs. Heterolytic fission will occur. Heterolytic fission occurs, and this pair of electron will move here. You have CH3, 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 this with plus. So here you will find that the carbon with the positive charge, it is carbon with the positive charge is bonded to 3 other carbon atoms. तो ये जो कार्बन एटम है, this is now tertiary carbon. Therefore, we will call this as the tertiary carbocation. This is called as tertiary carbocation. Okay. If suppose यहाँ पे ये CH3 नहीं होता, H होता, तो this would have been giving you secondary carbocation. Okay. So that also I will write so that you will understand. यहाँ पे instead of CH3 there is a H here. So here Cl this will now again heterolytic fission होगा and you will get CH3, CH3, CH, C. Sorry, this will be plus Cl minus. So this is your secondary carbocation. So have you understood what is the tertiary carbocation? प्राइमरी कार्बोकेटाइन उसे कहते हैं जिसमें जो कार्बन के ऊपर पॉजिटिव चार्ज है वो एक ही कार्बन के साथ अटैच्ड है. यहाँ पे जिस कार्बन में पॉजिटिव चार्ज है वो 3 कार्बन के साथ अटैच्ड है, तो ये टर्शियरी कार्बोकेटाइन. यहाँ पे कार्बन which is having positive charge is bonded to 2 other carbon atoms, so it is secondary carbocation. Secondary carbocation. ठीक है. Now how can you determine the stability of these carbocations? One more type of carbocation is which we call as methyl carbocation, जहाँ पे मिथाइल ग्रुप के ऊपर कार्बन के ऊपर पॉजिटिव चार्ज है. So stability order देखें अगर हम, तो tertiary carbocation is more stable than secondary carbocation than primary than methyl carbocation. टर्शियरी कार्बोकेटाइन कैसे हम रिप्रेजेंट कर रहे हैं? यहाँ CH3, यहाँ CH3, यहाँ CH3 and this carbon is having a positive charge. ठीक है. इसकी स्टेबिलिटी ज्यादा है than secondary carbocation, जहाँ पे the carbon which is having positive charge is bonded only to 2 carbon atoms. ये secondary carbocation है. और primary carbocation ये होता है CH3, CH2 plus and more stable than CH3 plus. अब कोई भी चार्ज स्पीशीज जो होता है ना वो हमेशा अनस्टेबल होता है, तो उसको अगर स्टेबलाइज करना है तो ये जो चार्ज है उसको डिस्पर्स करना पड़ेगा या उसको नलिफाई करना पड़ेगा। अब CH3 ग्रुप्स ऐसा ग्रुप्स है जो कि इलेक्ट्रॉन डोनेटिंग ग्रुप है, मतलब इलेक्ट्रॉन इट हैज द टेंडेंसी टू गिव अवे इलेक्ट्रॉन। सो दिस इलेक्ट्रॉन्स आर गिवन टू दिस कार्बन, बिकॉज ऑफ विच दिस कार्बन के ऊपर जो पॉजिटिव चार्ज है वो डिस्पर्स हो जाता है या उसका इफेक्ट इज बिकमिंग लेस। सो देन इट इज स्टेबलाइजिंग, उसका चार्ज इज बीइंग डिस्पर्स्ड, सो देयरफॉर देयर इज नो चार्ज रिमेनिंग, सो देयरफॉर दिस इज मोर स्टेबल। यहाँ पे तीन ऐसा ग्रुप्स है जो कि ये पॉजिटिव चार्ज को डिस्पर्स कर सकता है। यहाँ पे ओनली 2 कार्बन्स आर देयर व्हिच आर डोनेटिंग ग्रुप्स, मिथाइल ग्रुप्स आर डोनेटिंग ग्रुप्स, सो इट विल डिस्पर्स दिस कार्बन का positive charge to a lesser extent than this one, and here you will find only one methyl group is there, so therefore this will be donating the electron towards the carbon with positive charge and making it stable. तो ये जो stability है of the carbocation is governed by inductive effect. Inductive effect वही होता है ना, electron donating group will donate the electron, because of which carbon will have partial positive charge and the next carbon will have partial positive charge, this one will have partial negative charge. So that is what we call as inductive effect. So here what I am saying, the stability of this carbocations are governed by 3 factors. One is the inductive effect, okay, inductive effect जो कि हमने अभी ये देखा, this is what we call as inductive effect. Then there is resonance effect जहाँ पे conjugated systems है, so resonance effect जहाँ कार्बोकेटाइन के साथ there is a conjugated system, जैसे alternate double और single bond है, तो resonance effect के कारण भी कोई कार्बोकेटाइन can become stable, so that is resonance effect, and also hyperconjugation effect. Okay, so let me give you one example of a resonance effect. जैसे ये CH2 डबल बॉन्ड CH2 प्लस, ये एक कार्बोकेटाइन है, isn't it? So there is a double and single bond. Now what will happen? This pair of electron will move here to this carbon. Okay. So now how will you have your carbon atom? It will have this carbon will gain a positive charge. This will have CH double bond CH2. So this is the resonance effect where the कार्बोकेटाइन is getting stable. दो रेजोनेंस स्ट्रक्चर बन गया, मतलब ये कार्बोकेटाइन is more stable. Okay, ये इंडक्टिव इफेक्ट के अकॉर्डिंगली we can understand the stability of the कार्बोकेटाइन. ठीक है. One more effect is there which will govern the stability of the कार्बोकेटाइन, that is what we call as hyperconjugation effect. Hyperconjugation effect. Okay, उसका भी एक एग्जाम्पल लेके समझ लेते हैं. हाइपरकॉन्जुगेशन इफेक्ट, हाउ डज इट मेक द कार्बोकेटाइन मोर स्टेबल. फॉर एग्जाम्पल CH3 CH3, I write it here. Okay, this is positive charge and this is CH3. ऐसा है सब. This is a carbocation, isn't it? So मैंने क्या बताया था, जितना ज्यादा मिथाइल ग्रुप्स है उतना ज्यादा हाइपरकॉन्जुगेशंस यू विल ऑब्जर्व. सो यहाँ पे 2 हाइपरकॉन्जुगेशंस है, तो अगेन यू कैन show the hyperconjugations as ये CH3 जो है हम इसको इस तरह लिख लेते हैं so that things become clearer to you. H H H, ठीक है, a bond is there, so what will happen, this pair of electron will move here. Okay, so the electrons will nullify the effect of the positive charge, and now you have C with H here and H plus here, there is no bond here, double bond C H CH3. Can you observe? So here the positive charge over the carbon is getting decreased. Again ये भी ये इधर चला जाएगा, फिर Inductive effect, resonance effect, hyperconjugation effect. All of them make the carbocations more stable. Okay? So that is how you can understand the stability of the carbocation, which is a reactive intermediate. Reaction chain between this is being formed. Okay? So I will stop here today. We have learned three things today. What is resonance, what is hyperconjugation, and the reactive intermediate carbocation. Next time we will take another reactive intermediate which we call it as carbanion. Also we have learned about the relative stabilities of the carbocation. Tertiary carbocation is most stable, then secondary, then primary, and lastly methyl. A methyl group where there is no CH3 is there. So therefore this is the least stable one. Okay? And three factors govern the stability of the carbocation. One is inductive effect, resonance and hyperconjugation. इंडक्टिव भी हमने डिस्कस किया था. व्हाट इज इंडक्टिव इफेक्ट, रेजोनेंस इफेक्ट आज हमने डिस्कस किया, और हाइपरकॉन्जुगेशन. बोथ इंडक्टिव, बोथ all of them, inductive, hyperconjugation and resonance effect, all of them make the carbocation stable. Okay.